Hi everyone, this is Mehboob Ali, PGT Chemistry, Kendra Vidyalaya Byawar. In this video lesson, we will discuss about the chapter Solutions, part 3rd. In this video lesson, we will discuss the topic solubility and we'll also discuss about Henry's law. Wait, let's start. So we start with the solubility. So the question arises that what actually solubility is. So the solubility is the maximum amount of a substance that can be dissolved in fixed amount of solvent at specific temperature. So this is solubility. For example, the solubility of NaCl at 25 degrees Celsius in water is 360 gram. So this is 360 gram per kg. So this is the solubility of sodium chloride. So what do you understand with this one? It means this value of solubility means that 1 kg of water can dissolve 360 gram of NaCl at 25 degrees Celsius, not more than that. So this is called solubility. Okay. So what happened when this maximum amount of solute is already dissolved in the solvent? So that kind of solution is called saturated solution. See, so what saturated solution is? So saturated solution is the solution in which no more salt can be dissolved at particular given temperature and pressure. So that kind of solution is called saturated solution. Okay, so what happen if we add some more salt in the saturated solution? Suppose this is a saturated solution and we add 5 more gram of NaCl. So what happened to this NaCl here? So this NaCl, this extra NaCl will remain as such as undissolved solute in the solution. It will not dissolve because the solubility, the maximum solubility of the water or the solvent has reached already. So does it means that there is no dissolution process? No. Actually, the dissolution process is still carrying on. Then why this salt is not dissolved more further? So actually there is a dynamic equilibrium between the saturated solution and the undissolved solute. So the dissolution and the precipitation means the precipitation process takes place with the same rate, with the equal rate in the equal time. So the amount of solute that is dissolved in the solvent, same amount of the solute get undissolved and get precipitated in the solid form. So solubility of solid in liquid. Then the factors affecting are, first is nature of solvent. So here I would like to mention a principle like dissolves like. It means the ionic compounds dissolved in polar solvents and covalent compounds dissolved in non-polar solvents. Temperature, so solubility is directly proportional to temperature. It means as we rise the temperature, the solubility also get increased. This is true for solid in liquid only. Third, so this statement is valid for endothermic reactions only. It means if the dissolution is endothermic, then the solubility increases with temperature, but if the dissolution is exothermic, then the solubility of solid become inversely proportional to temperature. It means we cannot simply say that solubility is directly proportional or inversely proportional to temperature. It depends on the type of reaction, whether it is exothermic or endothermic. If the dissolution process is endothermic, then the solubility of solid is directly proportional to temperature, means increase with increasing temperature, and if it is exothermic, it is decrease with increasing temperature. Third one is pressure. So there is no effect of pressure on the solid and solubility of solid and in liquid, because the solids and liquids are highly incompressible, so there is no effect of pressure on them. So next is solubility of gas in a liquid. So what are the factors that affect this solubility? These are nature of solvent. Here also like dissolves like, means the ionic compound dissolve in polar solvent or the covalent compounds dissolve in non-polar solvents, because the molecular interactions are same. Okay. Second is temperature. So in this case the solubility of gas decreases with increasing temperature. So or you can write the solubility of a gas is inversely proportional to temperature. As you rise the temperature, the solubility of gas get decreased. That you see in summer seasons. As you put your soda bottle or your soft drink bottle on the table, as the temperature rises, as the heat rises, the solubility of carbon dioxide in the soft drink get decreased or the taste get changed. Okay, third one is pressure. So solubility of gas increases with rising pressure, and this effect of pressure is governed by a law that is called Henry's law. So to better understand the Henry's law, we will discuss an experiment. See, here you can see a container that has some water and a gas is filled over it, and on this there is a piston, and on this piston some weight is put to increase some pressure. Okay, here the pressure is equal to W1, and here the pressure is exerted by three weights W1, W2 and W3. So as we increase the pressure, the solubility of the gas get increased. So see, as we increase the pressure, you can see the gas more gas molecules get dissolved in the solution, in the solvent. So from this activity, from this experiment, we can conclude that the solubility or the mole fraction of gas in the solution is directly proportional to the partial pressure of gas over the solution. This is the Dalton's law that you have already studied in class 11, but in Henry's law we will write this statement inversely. See, Henry's law. So Henry's law is stated as the partial pressure of a gas in vapor phase, that is P, is directly proportional to the mole fraction of gas, that is X, in the solution. And mathematically this law can be written as P is equal to KHX. Okay, what KH is? KH is the Henry's constant and X is the mole fraction of dissolved gas. So greater the mole fraction in the solution, greater the partial vapor pressure over the solution, or you can say inversely that greater the partial vapor pressure of gas over the solution, more will be the mole fraction of dissolved gas in the solution. Now we discuss something about Henry's constant. So Henry's constant Kh is the function of nature of gas. Function of nature of gas. So it means that the value of Kh depends on the nature of gas. Second, solubility of a gas is inversely proportional to Kh value. Means if a gas has higher value of Kh, it means its solubility is low, or if a gas has low value of Kh, it means its solubility in a particular solvent is high. Third, Kh is directly proportional to temperature, means the value of Kh also depends on temperature. As the temperature rises, that means the value of Kh increases, and if the value of Kh increases, it means the solubility of gas decreases. That you saw in the Henry's constant, Henry's law. So next is applications of Henry's law. So first application, see, soda water bottles are sealed under high pressure to increase the solubility of carbon dioxide. So in summer season you all use soda bottles or soft drinks. So these soft drinks have dissolved carbon dioxide in them. So to increase the solubility of carbon dioxide, these bottles are sealed under high pressure, so more amount of carbon dioxide get dissolved in the bottles. Second, bends in scuba divers due to release of undissolved gases in the blood. So friends, bend actually it is a medical term, or it is a medical condition. So this condition arises due to release of undissolved gases in the blood. What happened when scuba divers goes under deep sea? So due to increased pressure, according to Henry's law, so the cylinder of the breathing gases that they carry with them, so these gases under more or high pressure dissolved in high amount in the blood due to increased pressure. But when these scuba divers come to surface, the pressure decreases suddenly, so the dissolved gases suddenly get undissolved, and due to release of these undissolved gases, the blood capillaries get blocked, and this condition cause a very severe pain. This medical condition is called bend. So to avoid the bend, the scuba divers carry the mixture of air or the oxygen that is mixed with the 11% helium, because the solubility of helium is low, so it dissolved less. Third one, at a high altitude the climbers suffer from anoxia. Means what happened there? At high altitude the pressure of air is less, so the amount of oxygen is also less, so less amount of oxygen get dissolved in the blood and less oxygen is supplied to the brain. So under this condition the climbers cannot think properly. This condition is called anoxia. They feel weak. Okay, next, what these are the applications. Now discuss about the limitations of Henry's law. So friends, Henry's law is valid only if the pressure is low. At high pressure it is less accurate. Okay, second, if the temperature is not very low. Friends, see, the pressure should be low and the temperature should not be very low, otherwise the Henry's law does not work properly. And third one, the gas should not be highly soluble, Fourth one, the gas should not react chemically with the solvent, or there is no association or dissociation of gas in the solvent. If these conditions arises, then the Henry's law get limited. It will become less accurate. Okay, so friends, this is the video lessons and about the solubility and Henry's law. Thank you very much. Like, share, subscribe and comment this channel, and note the definitions, examples and the formulas that are given in this video lecture. Thank you very much.